So now we've seen the 3D viewer for the scatter plots. I'm going to show you the latest version of the 3D viewer for the volume rendering. So here we have a data set which is for the L1448 region. So this is the CO data cube, and then we also have a dendrogram that goes with that, because I'm going to highlight some of the selections from dendrograms to the volume rendering. So let's create a volume rendering view first. So as before, the viewer looks actually very similar to the one for the scatter plot. So I'm going to basically make it so that the stretch is a little bit more, so we can actually see the data. So basically, as before, we have controls down here that relate to the actual the viewer itself, and then controls here that relate to the actual the layers that are being shown. So for example, the scatter plot. So the idea is, once we combine the scatter plot and the volume renderings, this panel down here will still be the same. And if you're looking at a volume rendering layer, then you'll have controls that are typical of volume rendering, and for the scatter plots, you'll have the scatter plot controls here. Okay, so as before, we can easily stretch the data. So we have the box essentially similar to before. It just shows the boundary of what the limits of the data, and we can control the stretch in the X, Y, and then Z direction. So I can actually make it a little bit flatter here. And we can turn around and look at the data. We can of course change the color. So for example, if we want to make it more reddish, we can do this. And then I'm going to change it back to grey for now. As for the Scatterplot viewer, you can change the transparency of the data interactively like this. Okay, so now what I'm going to do is I'm going to create other more traditional viewers. So I'm going to show the dendrogram viewer and put it up here. And I'm going to make a 2D viewer of the data. So here we go. So this is the actual data. And so I'm just going to slice to where we can actually see something more interesting going on. Okay, so as for the Scatterplot viewer, the 3D volume rendering here recognizes selections. It doesn't yet support selections in 3D, but we can, for example, select a feature in the dendrogram. So if I do this, then the feature is highlighted both in the volume rendering and in the 2D plot. So you can see now the region is actually very nicely highlighted here. And I can go and select another region, so I can make another subset, for example, this leaf here in the dendrogram. And again, I can see in green the subset. So you'll notice the stretch adjusts. It's trying to show the different subsets at the same time. We can of course control the transparency of each layer. So we can say, for example, if we want the red to be a little bit more transparent, we can make it fade a little bit. Okay, and so then we can turn around like this. What we can do as well is we can do some selections. So I'm going to do a selection in the 2D plot here. So I'm going to create a new selection. And so what will happen here is this selection is going to be shown in blue. So we can see all the parts of the dendrogram that are affected essentially by this selection. And then in this view here, we can see the data being shown in blue. Now you'll notice that the blue color here is brighter in certain places, so by default it will show the actual data color coded by the subset. It's actually also possible to show the whole outline of the subset region. So if I go to the layer for the blue here and I click on outline, then I will actually see the full kind of cylinder shape that was used to make the selection, and I can switch between that and showing just the data itself that was selected. Okay, so the last thing I want to show is how we can show multiple volumes in the same viewer together from different data sets. So what I have here is I have two spectral cubes for the B5 star forming region. One is C18O and the other one is HCO+. The HCO+ one was reprojected already before opening this in glue, so that it would be on the same grid as the C18O data. In future we can actually make it that this happens in glue automatically. So I'm going to drag the C18O data here onto the canvas and make a 3D volume rendering plot. So I'm going to make this bigger. and then I'm going to adjust the limits to see the data more easily. So you can see in this case that actually most of the data is contained within a very thin slice. So this is a place where the stretching can be handy. We can also actually change just the actual limits in pixel coordinates that we use to show the data, and then the cube itself won't have to change. And if we want, we can then add some stretch on top of that. Okay, so we can see this interesting 3D structure. So bearing in mind this is not real PPP, position, 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 but the actual third axis along the vertical direction here, the z-axis is the velocity. Okay, so what I can do is I can actually now drag the HCO plus data onto the viewer, and again I have to go to that layer and adjust the limits. We can make the defaults more sensible in future. And this actually contains both volumes. Now, of course, it's hard to see because they're both shown in gray. So what we're going to do is we're going to show one of them in red, and the other one we can give it a slight bluish tint, just to make it a little bit more obvious. And so what we see now is we can actually see both data sets. The reddish regions are regions where essentially there's a lot more HCO plus, and the other regions, the gray regions, are the ones with more C18O. So we can really see the kind of spatial the differences in the spatial distribution for the two molecules. We can see an interesting structure. So here there's a region with a lot of HCO plus, and there's also a region here in this little tail which has some, and then there's another region here that seems to be on its own that's essentially got a lot of HCO plus emission but not so much C18O.